Chapter 2, Section 8 is about literal equations and dimensional analysis. We're going to break this section into two parts. The first one is going to be literal equations, where you're going to be rewriting an equation and solving for a specific variable within that equation. Now, this is going to look different than when you were solving equations previously, where you actually got an answer like x equals 4 or y equals -2. For these types of problems, you're solving an equation or some expression, and you're not going to get the traditional answer like that. Instead, you're going to get x equals, and it's going to be a new equation or new expression. Then we'll get into dimensional analysis, which is when you're dealing with something in a specific unit and you're trying to convert it to a new label or new unit of measure. So we're going to be doing some converting in between something that maybe was measured in feet per second, and then they want you to change it so that it's miles per hour. I want to go over first with the literal equations, talk to you through some examples, and then we'll do some practice here. So, for example, you'll be given something that looks like this one, 3x plus 7y equals 10. And they are asking you to solve for the letter y. So, whenever you look for the variable, I usually will try to circle it or something like that so I know what exactly I'm trying to solve for here. And then the first thing I suggest, especially if you're not sure what to try to move first, is maybe try to cover up or put your finger over the 7y to kind of isolate it and look at everything else that's around it, because those are the things that you're going to want to move first. So if I don't think about 7y being there, I've got this 3x over here that I need to move. I'm going to do that by subtracting 3x from both sides of the equation. Now, when you subtract 3x from the left-hand side, those are going to cancel. Over here on the right side, though, you can't combine 10 and that minus 3x. You have to leave them separate, because 10 doesn't have an x for you to combine it with that 3. So they wrote it 7y, because that would be left on the left-hand side, equals, and they put the minus or negative 3x plus 10. And they put that negative 3x first. It's okay, though, if you had this switched and you said 10 minus 3x instead. Now, we still have 7 sitting in front of y, and right now those two terms are being multiplied to each other. So what we need to do to finish is divide by 7. And when you divide by 7 over here, you're going to divide everything. So I just draw a big fraction bar, and I put the 7 underneath the entire expression. So then if I'm looking at what's left, these 7s are going to cancel, and I drop down the y and the equal sign, and it says negative 3x plus 10 all over 7. So see how they still have that big fraction bar. And this is where you're going to leave your answer. Like I said, you're not going to get that traditional answer of y equals 2 or x equals 4. You're solving these equations for a new variable, so there's still going to be a lot of stuff that you can't really do anything with because they're not giving you any more information about what x would be for this problem, for example, for us to solve for y. Now, this next example is going to show you why it's really important for you to be able to do something like this. In future years, like when you guys go on to geometry and Algebra 2 and maybe even some math classes beyond that, there's going to be times when you are working with a formula. And with the formula, you're going to want to be able to maybe rewrite it so that instead of solving for area or volume, maybe you need to figure out what the height is of the shape or the base length. And so being able to rewrite the formula or kind of rearrange it and manipulate it will allow you to be able to solve those equations for a specific variable that they're maybe asking you for. Now, this equation that I have here says capital A equals 1/2 BH. Now, that's actually the area formula for a triangle. Area equals 1/2 times base times height. Now, if you don't know what those letters stand for, it's not a big deal right now, because I'm not asking you to find area of a triangle. I don't even have a triangle shown here for me to do that. What I want us to practice is, again, rewriting this equation This time, though, we're going to solve it for h. To get yourself started, you're going to want to get rid of that fraction. So we've got 1/2 right now. Now remember, to get rid of a fraction, you multiply by its reciprocal. So I'm going to multiply both sides by a 2 over 1, or you can think of that as just multiplying by a 2. Now when I do that over here, the 1/2 and the 2 over 1 are going to cancel, and I bring down the BH. And then on the left side now I have that 2 times A. Now I still need to get h alone, and right now there's b times that h. So to get rid of b, we're going to divide both sides by it. So now those b's cancel, and I drop down that h equals that 2 capital A all over b, and this would be your new equation. So on an example like this one, if I knew what the area of the triangle was and I knew what the base was, I could plug that in to solve for the height. And so that, again, like I said, would be an example of when you might see this. So let's practice one here together. Again, this time it's not going to be worked out for us, so I want us to solve this one. Now we're still using the same equation that we did up above, but this time they want us to solve for b instead of solving for h. Now remember, on that last one we wanted to get rid of the fraction first, so we need to do that again. We're going to multiply both sides by 2, or 2 over 1. When we do that, we're going to have 2 times that capital A equals, again, the 1/2 and the 2 are going to cancel, so equals BH. Now again, solving for B, so I'm going to divide both sides by the H. And so I would have 2 times A all over H equals your B. So very similar to that last example, it's just we were solving for B instead of solving for H. So I want you guys to try this practice problem and solve this equation for M. So for this one, we want to solve for M. The first thing I would have done is subtracted B. So it says y minus b equals mx. Now I still have x next to m, so then I would have divided by x, and I would have divided all of that equation on the left-hand side by x. So now it says y minus b all over x equals m. Or some of you might have switched it around and put m first, and then y minus b all over x. It's okay to give me either one of those expressions there. Okay, there's one more practice problem here for you to try. So for this one, I would have started by subtracting the z. So your new expression should say u minus z equals vw. Then I would divide by w, and again divide the entire left side by that as well. So we should have had u minus z all over w equals v. And again, you could have switched that around and said v equals u minus z all over w. Now moving into the second part of this section, we're going to get into that dimensional analysis that I mentioned earlier. And this is when we are doing conversion. So we have something given to us in a specific unit or units. And what they want you to do is convert it. So they want you to change the units that you currently have to new units. An example of this would be if they wanted you to figure out how many miles were in a 10K run. Now, capital K stands for kilometers. Kilometers is something that's used within the metric system. Now, most of us are used to using our own system because here in the U.S. we don't use the metric system primarily. So what we're used to seeing is miles instead of kilometers. So you know that 1 meter is equal to 1.094 yards, and they're also giving us information saying that 1 mile is equal to 5,280 feet. Now, something that we call this is kind of just a way to help you remember this is we refer to this as the railroad track method. It's basically going to be like a really big fraction. So I'm going to draw a really big fraction bar here, and I'm going to cut this fraction bar into smaller chunks so it kind of starts to appear like it's a railroad track in a way. To get yourself started, you always take the first unit or whatever unit they're giving you. So in this case, it's that 10K, and you put that in the first kind of fraction, if that's what you want to think of these as, or if you want to think of these each as like boxes or something, however you want to think of them as. You put that 10K first. Now, sometimes it'll be like you're traveling 10 kilometers for every 2 seconds, something like that. In which case, if they're giving you a second unit of measurement, that's going to go right underneath the 10K. But they don't do that for this problem. Now, a little bit of information is needed about the metric system. So a lot of times they'll give this type of information to you. Not always, but sometimes they will. So something that we know about the metric system is that a kilometer, 1 kilometer, is the same as 1,000 meters. Now, if you notice what they did here is they put kilometers on the top and they put kilometers on the bottom. The reason why you do that is because you want these labels to cancel each other off. So you can see how I can cross those K's off now. Eventually what I want to see happen is I want all of my labels to go away and I want to be left with miles because I'm trying to get 2 miles for my last conversion. So I got my kilometers to go away. Now what I've got here are meters. On the top I've got 1,000 meters. And you can see how they put 1 meter down here on the bottom, again, to get these meters to cancel. Now what's going to go on the top is something that they gave us from the problem. They said that 1 meter is the same thing as 1.094 yards. So up here on the top of this 1 meter, we're going to put that 1.094 yards. Now if you look at the next kind of area in our dimensional analysis here, we've got a blank space again on the top, and that's over 1 yard. Now my yards again can cancel because I got 1 on the top, 1 on the bottom. To kind of see, like, well, what do we want to get to next? Look at what's on the bottom of the fraction at the very end here. Feet. So we probably want to get feet up above that yard. So if you know this, there's 1 yard for every 3 feet that you travel. So 3 feet is the same thing as 1 yard. If you've ever seen a yardstick or like a meter stick before, that is about the same length as 3 feet. So if I put like 3 rulers side by side by side, that would be about the same length as a yardstick. So again, now I can cancel off these feet. And the last thing I need to fill in up here is the miles, because they've got that 5,280 feet on the bottom, so the 1 mile would have to go on the top. Now, once you've gotten to that label that we were trying to convert to, so I needed miles, and I have that. Miles is done. All of my other labels have canceled off. So the next, the next step is to multiply across the top. So you take 10 times 1,000 times 1.094 times 3. And then you can do times 1. Now, sometimes when you have the 1s in there, you don't really need to multiply them if you don't want to, because multiplying by 1 is not going to change your answer at all. And on the bottom, you're going to have 1, 1, 1, and that 5,280. Again, you don't really need those 1s if you don't want to include them. So now you multiply across the top and across the bottom. Now when you multiply across the top here, you should have gotten 32,820. And then across the bottom, you should have gotten 5,280. And then the last step is to divide, and this comes out to be 6.2, and this would be miles. So a 10K is about 6.2 miles. So let's take a look at this next practice problem together, and then I'll let you guys try the last one on your own. So this practice problem says that a car travels 100 feet in 2.8 seconds. We want to figure out what the velocity of the car is in miles per hour. So draw your big fraction bar. To get yourself started, you need to put in the first kind of chunk here the information that they give you. Now this one is actually giving you 2 units of measurement. So remember what I said is that you're going to put the 100 feet on top and that 2.8 seconds on the bottom. Now what they are asking you to convert to is miles per hour. So we need to get feet to miles and the seconds to hours. I would say most of the time, students find time a lot easier to do than the distance. Because a lot of us probably know basics about time. Like we know how many minutes there are in an hour, how many seconds there are in a minute, we know how many hours there are in a day, those kinds of things. So if I have seconds and I'm trying to get to hours, I maybe don't want to do a direct conversion. Like I don't want to go straight from seconds to hours. So instead, I'm going to go seconds to minutes. Now there are 60 seconds in 1 minute. So remember, I have seconds on the bottom right now, which means that the next time I write seconds, I want it to be on the top up here so that it'll cancel off with the seconds on the bottom. I'm going to put 60 seconds on the top over 1 minute on the bottom. I'm going to do this again, but to go from minutes to hours. And so there are 60 minutes, and again, we put minutes on top so that it cancels off with the minutes on the bottom. And we put 1 hour underneath that. So if we kind of just follow along here, we've got our seconds canceling and our minutes canceling, and we've got hours left on the bottom, which is one of the units I wanted to get to. Now the other one that I need to convert is feet. I need to convert feet to miles, okay? So feet, we had that up here in this problem here, feet to miles. We use this information again. 1 mile is the same as 5,280 feet. So coming down here, I need to put that 1 mile on the top so that the 5,280 feet can go on the bottom so that this feet on the top will cancel off with this feet on the bottom. Now, like we did on the last problem, we've got miles on top, we've got hours on the bottom. Those are the 2 labels that they want us to get to. We're done with the converting. Now we do the multiplying. So on top, we're going to take 100 times 60 times 60. And again, you can include that 1 if you wish. On the bottom, you're going to take 2.8 times 1 times 1 times 5,280. On the top, when you do that, you should get 360,000. And on the bottom, you should get 14,784. Last step is to divide. And this comes out to be about 24.35. And that would be miles per hour, mph. So I want you to try to do this last practice problem. You're trying to convert 50 yards in 10 seconds to miles per hour. Use information from those previous 2 problems to help you understand or help you do the conversions. If you don't remember how to go from like yards to feet or feet to miles, we just did 2 examples that kind of include some of that information for you. So use those previous problems to help you do this one if you need that. So for this problem, I would have started again maybe with time. So very similar to that last problem, I start by doing 60 seconds over 1 minute, 60 minutes over 1 hour. Now for my yards, I need to go yards to feet first before I can go to miles. So up in that first example I showed you guys, we talked how there are 3 feet in 1 yard. And then for your yards to miles, there's 5,280 feet in every 1 mile. If I go along here, my seconds cancel, my minutes cancel, I'm left with hours, my yards cancel, and my feet cancel, I'm left with miles. Then you should have multiplied across the top. So 50 times 60 times 60 times 3. Then you should have multiplied on the bottom. 10 times 1 times 1 times 1 times 5,280. When I multiplied, I got 540,000 on the top, 52,800 on the bottom, and this converts down or breaks down to 10.23 miles per hour.